Dear students, today let us understand the exact length and content of the answers to the two model question papers which I had provided you earlier. These two question papers cover almost all important questions, so that I want you to compare the answers which I am providing you now with those which you have written earlier. The question paper which I had provided was this one. This is one of the two papers which I had provided earlier. You have observed that there are 10 main questions, and each main question is having the subdivisions, maybe 3 or 4 as per our college rules. 4 subdivisions are allowed maximum, and 3 divisions have been made in most of the questions here. And you know that you need to answer any one question, one main question from each module. For practicing purpose, I had told you to answer every question here without leaving the choice. But in the exam, you are allowed to choose any one of the two main questions. For example, this is the question number 1. If you choose question number 1, you have to answer every individual sub questions. If you choose question number 2, then you have to answer all these 4 subdivisions, means sub questions. So you choose any one main questions, any one of the two main questions, and answer all the sub questions of that particular main question. If you choose one sub question from first main and 1 or 2 other sub questions from the other main question, then of course both will be evaluated, but whichever gets higher marks, that will be considered for final awarding of the marks. So that it is good to remember that you have to choose any one of the two main questions from each module, and you have to answer all the sub questions from the same main question that you have chosen. So in this way, total 10 questions have been given and you have answered them. Let us now verify whether your answers are correct or not. So this is the first model question paper, in which the first question was state and explain Wien's and Rayleigh-Jean's laws of energy distribution, and you have to mention their relations. So before telling you about the answers of this particular question or other questions, I have to tell you one more important point, that the two main questions which have been given here, the two main questions are not selective from the two different parts of the first module, because sometimes some students think that the first question will be given from the first half of the first module syllabus, and second question will be given from the second half of the module. But that is not correct. Questions will be mixed. Questions may be chosen from both parts, first half and second part of each module. Therefore, you have to remember that there will be the intermixing of questions. So don't do the selective study. For example, in module number 2, for example, you can observe that classical and quantum free electron theories are discussed in the first half of the syllabus of module 2, and in the second half we had discussed the superconductors. But while framing the questions, we have selected the question from both the parts. You are observing here: explain failures of classical free electron theory, describe dependence of electrical resistivity on temperature in extrinsic semiconductor. These two questions are from first part of the second module, whereas explain type 1 and type 2 superconductors is from the second part. So that you have to study the complete content of each module. Don't make any selective study. Right. Let us come back to the solutions or the answers to the questions. Question number 1 I have already mentioned that it is about the Wien's and Rayleigh's laws of energy distribution of the module number 1. Since we need only statement and brief explanation and it is for 5 marks, your answer should be precise. You know that the statement is written in mathematical form, so it is good to write this equation and you have to explain each symbol used. While writing any answer, if you use an equation, immediately after writing the equation, you must have the practice of explaining each and every symbol. For example, you are observing here that E lambda is the energy density within the wavelength range d lambda, and lambda is the wavelength of a specific radiation emitted at a temperature T. And C1 and C2 are some constants. You need not discuss about those constants here since it is for 5 marks. And it is asked to mention the limitation also. That's why you need to write the demerit. You know that Wien's energy distribution law is valid only for the shorter wavelength region of the electromagnetic spectrum of black body. Hence, the demerit or the limitation is that it fails to explain the longer wavelength region of the black body radiation spectrum. So, answers are precise. You need not give any more explanations, especially for this question. So, your answer should be precise to the question that has been given. So, before writing the answers, it is good to read and understand the given question. And second part of the question is that Rayleigh-Jean's law of energy distribution. So, Rayleigh-Jean's law is given by this equation where the constants, here again E lambda is the energy radiated within the wavelength and T is the temperature, K is the Boltzmann constant here, and demerit is that it is valid for the shorter wavelength region, means it is valid for the longer wavelength region, and it could not explain the radiation, especially the ultraviolet radiation emitted by a black body at a given temperature. So, this is the limitation of the Rayleigh-Jean's law, which is also known as ultraviolet catastrophe. And second question was derive an expression for eigenfunction and eigenvalues for a particle in a potential well of infinite depth. Normalize the wave function and discuss the probability density for the case of ground state. So, here you are observing that marks to be awarded is 10, and the question is also clear that you have to derive the expression for the eigenfunction, you have to discuss the energy eigenvalues of the particle, you have to normalize the wave function and discuss the probability density. There are 4 parts. First part is the derivation of eigenfunction that requires this diagram, and Schrodinger's equation is required, and for this particular potential well, since when the particle is inside the well, what do we say? The potential energy is 0 and wave function is not 0 when the particle is inside the well, because inside the well, since particle is present, wave function cannot be 0. If the particle is free to move within the potential well, then it can have higher kinetic energy, hence the potential energy is ignored and mathematically it is treated as 0. And the first wall is taken at x is equal to 0 and x is equal to A represents the position of the second wall. It is the one-dimensional movement of the particle. Therefore, one-dimensional equation, that is Schrodinger equation, is considered. Since V is 0, the equation is reduced to this form, and on simplifying this equation you will get it by comparing this equation with the simple harmonic equation, it is possible to get that 8 pi square me by h square is equivalent to square of k. Here k is not Boltzmann constant. This is a wave number that we are going to derive. Even in this derivation, we will derive one more expression for k. And solution is considered and conditions to be applied. Since we have already learnt in the class, I am not going to explain in detail about every individual step. So this requires derivation of wave function, and then you have to discuss the eigenvalues. Eigenvalues are energy values in this case. Since you have derived the expression for k square, n square pi square by a square is expression for k square here, and another expression is 8 pi square me by h square. You can compare them and obtain n square pi square by a square equal to this, and e is n square h square by 8 ma square. So this equation gives you the general expression for energy, using which you can express the energy values at different energy states. When the particle is in the ground state, you know that n value is 1, it's not 0, because if you put n equal to 0, what happens? Total energy of the system becomes 0. It is not true, it's not correct practically. Therefore, n is equal to 0 is an invalid solution. Minimum value of n is 1. Hence, n is equal to 1 is taken for the ground state, that is the lowest energy state, that is also known as 0 point energy state. And by putting n value equal to 2, you will get the energy for the first excited state. 3 gives you, n equal to 3 gives you the energy for the second excited state, and so on. You can calculate the energy values in this way by putting the values of n, which is an integer, positive integer. This is second part of the derivation. And in the third part, you have to obtain the expression for a constant, because in the first part of derivation a was unknown. Therefore, we are going to obtain the value for a. For that, you need the normalization condition, that is integration of square of the modulus of the wave function within the limits of the system. Here limits of the system are x equal to 0 and x equal to a. If you take the first position as x1 and second position as x2, x1 is 0. That is the initial position of the particle at the first wall, and for second wall is wall of the potential well is at x equal to a. Therefore, limits are taken to be 0 to a. And expression for psi was derived in the first part of the derivation, which is substituted, and on simplifying you will get the actual solution for a, that is root 2 by a, which you substitute in the equation for the wave function. That is the third part of the derivation. And in the fourth part, you have to discuss the probability density of the particle for the ground state and the for the first excited state. Here it is wrongly mentioned. For the particle in the ground state is mentioned. This is wrong. This one. This should be actually the first excited state. For the first excited state, n is equal to 2. So by putting those values, you can calculate and obtain the expression, and you have to discuss this graph. This is the answer that is required for this question number 2a. Is it 2a? 1b, I think. Yeah. For question number 1b, you need this much answer, for which marks will be 10. For example, for first part of the derivation, you may get nearly 5 marks, and second part, that is for discussing the eigenvalues, 2 marks may be awarded, and for deriving the expression for a, you will get 1 mark, and finally for discussing the probability density, 2 marks. In this way, marks will be awarded in our scheme of evaluation. Right. Let us go to the question number 1c. In question number 1c, the problem is given. Since the same problem has been discussed in earlier lectures, I won't give you any details in this case as it is already discussed. Okay, and in the question number 2a, what is a black body? You have to mention the definition. It will be for 1 mark, and explain the black body radiation spectrum with neat diagram. So black body definition is given. Black body radiation spectrum, you need to draw this diagram, and then you have to mention the experimental facts related to it. Like for example, at a temperature equal to 300 degree Kelvin, the total energy radiated is not very high as compared to that emitted at temperature 4000 and 6000 degree Kelvin. So lower the temperature, lower will be the total amount of energy radiated by a black body. That is the inference. And with increasing wavelength, there will be the increase of energy, and on reaching a maximum value, that decreases. And the peak will correspond to a particular wavelength, let us say lambda m. And when the temperature is raised, that lambda m decreases to a lower value. So peak shifts towards lower wavelength region. That was described in terms of the Wien's displacement law, lambda m. That is the wavelength corresponding to the peak of an electromagnetic radiation curve is directly proportional to 1 by t. I mean inversely proportional to t. And the product of lambda m t is constant. This is Wien's displacement law. In this way, you have to discuss the Stephen's fourth power law as well as the Wien's fifth power law. Question number 2b requires statement and explanation of de Broglie's concept of matter waves for 5 marks. De Broglie's statement is very clear here. It is stated that since nature loves symmetry, if a wave can act like a particle depending on the circumstance, then a material particle must also behave as well. This is the statement. In order to arrive at this statement, you have to give the background. That is, for example, interference and diffraction phenomena describe the wave behavior of light. Compton effect and photoelectric effect gives you the idea that the radiation can have particle nature also. So those backgrounds have to be discussed here in this paragraph, and then you have to arrive at the, what is this? The statement of the de Broglie's concept of matter waves and the equation described by him to be discussed. This equation. And then derivation of relation between particle velocity and group velocity. Mention the physical importance of the relation. So in the scheme of evaluation, for mentioning the physical importance, we will give you 1 mark, and for derivation 4 marks will be awarded, since total marks is 5. And this derivation requires the expression for group velocity, and then you have to derive the expression for d omega and dk, and then on substituting you will get the required solution. So this is the inference, physical importance of this equation, or inference of this equation. Right. And then question number 2d is a problem. So you may be observing that almost every problem is every main question is having one problem. This is the pattern that we usually follow in the examinations. So 2 or 3 theory questions will be given and 1 problem will be given, either for 4 marks or 5 marks. So which indicates that totally 25% of the question paper will be on problems and 75% will be on the theory. So that you have to study neatly the solutions of all the problems which I have solved in earlier lectures. So this problem was also discussed in the previous lectures, so that I am not going to explain in detail about it. And module number 2, this is about the classical free electron theory and the superconductivity. 3A requires the explanation of failures of classical free electron theory. Failures, in class I had explained 3 failures. There are few others, but important are these 3. These 3 you have to discuss for 6 marks. Each failure can be discussed for 2 marks. Specific heat, about the temperature dependence of electrical conductivity and relation between conductivity and electron concentration. These are the only 3 failures that you need to discuss. And in question number 3B, you have to describe the dependence of electrical resistivity on temperature in extrinsic semiconductor. This is where many students make a mistake in writing the answers. In class I have given you the lecture on the dependence of electrical resistivity on temperature in intrinsic semiconductor and extrinsic semiconductor. But here the question is only about the extrinsic semiconductor, so you need not write everything that I have been explained earlier. So in this case you have to draw the diagram, that is graphical diagram, related only to the extrinsic semiconductor. This is the curve at low temperature, and this is at the intermediate temperature, and this is at the higher temperature. So this curve was discussed by saying that at very low temperature, ionization of only impurity atoms takes place, because intrinsic atoms need higher temperature for releasing the free electrons, so that the resistivity decreases with increasing temperature because of the ionization, release of electrons by the impurity atoms. And within a specific window of temperature, neither the intrinsic atoms nor the extrinsic atoms release the electrons, therefore there will be the increase in resistivity. Once the intrinsic atoms start releasing the electrons, again resistivity decreases. This is very similar to the intrinsic behavior of the semiconductor. In intrinsic semiconductor, resistivity decreases with increasing temperature, but in extrinsic semiconductor, within a temperature range, let us say from, for example, 10 degree Kelvin to 500 degree Kelvin, you can observe this kind of curve. So the description of this graphical diagram is required for 5 marks. And explanation of type 1 and type 2 superconductors. Type 1 superconductor requires this diagram. You have to explain the magnetization versus the magnetizing field, and you know that there will be only one critical magnetic field, whereas there will be 2 critical magnetic fields here and here. In the case of type 2 superconductors, because of the second critical magnetic field, it is useful for especially the superconducting magnets. This is all we discussed in the class. Since it is for 5 marks, we distribute the marks, like for example 2.5 marks for type 1 and 2.5 marks for the type 2 superconductor. And it is acceptable even if you write a table to write the differences between type 1 and type 2 superconductor. I have written the answer in terms of the paragraphs. You can even select the important 5-6 points for each superconductor, and you can write in terms of the table. One column for type 1 and another column for type 2. But these diagrams are essential. I have found that in some of your answers which are submitted in terms of the assignment, the diagrams have been ignored. So diagrams are required. There will be 1 mark for each diagram. Again, this problem, it was discussed in the earlier lectures, so that no need to discuss further. This carries 4 marks. Merits of quantum free electron theory, question number 4A. Again, in order to discuss the merits of the quantum free electron theory, the three cases are considered: the specific heat, electron concentration, and temperature dependence of electrical conductivity. Just in the previous main question, 3a, you have observed that the failures of the classical free electron theory have been discussed. Those failures were overcome by the quantum free electron theory. How those limitations were overcome by this quantum free electron theory, that has to be discussed. Since it is for 6 marks, 2 marks will be awarded. And in case if the same question is given for 9 marks, we will provide 3 marks for each one that you discuss in this way. We have to describe the dependence of Fermi-Dirac distribution function on temperature and Fermi energy for 6 marks. And the marks which have given are only indicative. They are not the exact marks which we give even during the semester examination. It may change. For example, this derivation may be given even for 8 marks. Therefore, this is only indicative. So with the reference to this particular diagram, you have to discuss the 3 different cases of the Fermi-Dirac distribution function or the Fermi factor in terms of the temperature and Fermi energy dependence of the Fermi factor. That is, for E less than F at temperature equal to 0, for E equal to EF at temperature greater than 0 K in the third case, and in the second case at T equal to 0 if E is greater than EF, what would be the case? You have to discuss these 3 cases. That will cover the actual answer for this particular question. And application of superconductor in maglev vehicle. Diagram is essential to explain. With reference to this diagram sometimes carries 1 mark in the exam and 3 marks will be given for the explanation. So you have to explain every part of this maglev vehicle, the function of every part of the maglev vehicle as described here in this paragraph. Problem related to Fermi energy and Fermi velocity in a metal of electron density 2.61 into 10 power 28 per meter cube. Of course, this problem is also discussed in the class. Very simple one. You need to write the expression for Fermi energy in terms of the electron concentration n and substitute the given value n here. Other values are constants. H is Planck's constant. 6.625 into 10 power minus 34 joule second. M is 9.1 into 10 power minus 31 kg. Substitute the values and calculate it. And Fermi velocity will be calculated in this equation because energy, that is Fermi energy, is given by half mv square formula. On rearranging, you will get this equation and find the answer. 5a, question number 5a requires the derivation of expression for interplanar spacing in a crystal for 7 marks. So figure carries 1 mark and derivation for 6 marks, and we divide this derivation also 3 parts. For each part 2 marks will be awarded. For example, with reference to this diagram, you will write OP expressions in terms of x cos alpha, y cos beta and z cos gamma. For these 2 marks will be awarded. And in the next part you will take the Miller indices equation and simplify it, for which 2 marks will be awarded. For the remaining part 2 marks will be awarded. So D equal to square root A by square root of h square plus k square plus l square. You have to arrive at this expression because for a simple cubic crystal structure, A equal to B is equal to C. Therefore, you are taking A at in the place of B and C 2. Therefore, you are getting this expression. Procedure of determining Miller indices, 4 steps have been discussed. This diagram is required to explain it because we are taking an example. The question gives that explain procedure of determining Miller indices. So in order to explain the procedure, taking an example is essential. and in each step explain the procedure. Find intercepts x, y, z along crystal axis in terms of basis vectors. This is the procedure and this is an example. And express ratios of x by z to a, b and c respectively. So x by a, y by b, z by c to be taken. X was half of a, therefore half of a by a is taken. On simplifying, we will get half 3 by 4 and 1 by 1. LCM to be taken in the fourth part, of course. Here take the reciprocals first and then take the LCM. That completes the procedure. So you have to write all the 4 steps along with the diagram. Common mistake committed by some of the students is that they will forget drawing the diagram. They will straight away go to express the steps. If the same question is given for 3 or 4 marks, then it's okay. Without diagram and without the example, you can explain explain only the steps. But it is for 8 marks. So try to have the practice of explaining the steps along with the examples. And this problem. So in this question paper, almost the problems which have been given are discussed earlier. Therefore, I am not going in detail about them. Right. Here in this problem, you need to calculate the interplanar distance and the wavelength. Since a by square root of h square plus k square plus l square is the formula, h, k, l are given, substitute here, you will get d value. A is also given here and d can be used here for calculating wavelength. If the order of diffraction is mentioned, it's okay. You can take n value as per the instructions given in the problem. If it is not mentioned, just assume that it is 1. N is equal to 1. And with that assumption that n is equal to 1, I have calculated lambda value. Question number 6a. Definition of unit cell, number of atoms shared by unit cell, and coordination number. 3 parts are there. So you have to define the unit cell, for which 1 mark will be awarded, and then you have to explain how to obtain the numbers of atoms in each unit cell. So you will get, for example, since it is 7 marks, 1, 2, 3 marks will be awarded for that part of the answer. So 3 plus 1 will be 4. Remaining 3 marks may be awarded for the coordination number. Since it is again simple cube, FCC and BCC, 3 cases are there, 3 marks may be awarded here. So this is how we will award you the marks. Not necessarily 7 marks should be given here. We sometimes reduce the marks in the exam for the same content, but almost 6, 7 or 8 marks will be considered for this particular length of answer. Explain polar and non-polar dielectrics. This is the question. You have to explain what is a polar dielectric and what is a non-polar dielectric, and at least one example you have to mention. The same thing has been given here. This is the answer for this question. And problem again. For FCC structure, lattice constant is given. Calculate the interplanar distance. So only D has to be calculated. Very simple problem. Sometimes such simple problems will be given, but in some other cases, some complexity level will be higher. In module number 4, that is on the waves and rigid body dynamics module, derivation of expression for displacement of a damped harmonic motion. It is for 10 marks. You have to derive the expression and also discuss the different cases. It is not asked in this particular question, since it is not mentioned to discuss the different cases. You need not worry about it. For this expression, this derivation or this question, you have to derive only expression for displacement. For that you need restoring force, frictional force, because the damped vibrations are experiencing the 2 types of forces, the frictional force and the restoring force. and because of them the body tries to come back to rest, and on substituting the values and deriving you will get this particular expression. Y is equal to a1 e power minus b plus square root of b square minus omega square into t plus a2 e power minus b square minus omega square into t. If you derive up to this equation, it's enough. It will be for 10 marks. And this 4 marks question requires brief discussion on free vibrations, and you have to define the natural frequency. It is done here. A periodic force of maximum magnitude. This problem is given for 6 marks. Since it is little lengthy, 6 marks will be awarded for this type of problem. Sometimes 5 marks will also be awarded. It depends on the paper setter who chooses to give the marks, to alert the marks. Derive an expression for bending moment. For deriving this expression, you need the diagram. Without diagram, if you derive this equation, you will lose at least 2 marks. So that it is very essential. You have to take the diagram, you have to explain the diagram. Only then you have to start the explanation. Some students have the practice of writing only mathematical equations, which leads to the loss of marks. It is very essential to explain each and every step, because you are writing physics behind the equations. So that for every equation, it is essential to write the explanation. And in the second sub question, explain with diagram neutral axis and neutral plane. If you write only the definitions, it is not enough. You have to explain the 2 terms, that are neutral axis and neutral plane. Only then you will get the marks. 5, for example, 1 mark for the diagram and 4 marks for the other part. And you need to solve this simple problem. You have to calculate the moment, bending moment. The data are given in the problem, and you will find the answer on substituting the values. The last module, that is on laser and optical fiber, you have to derive an expression for energy density of laser in terms of Einstein coefficients. For this derivation, you have to draw this diagram and describe how to get the expression for R12, R21 SP and R31 ST. So all these 3 equations to be derived. Some students have the practice of writing these equations directly. That is not correct. You have to draw the diagram. You have to explain in brief about the rate of excitation, rate of stimulated de-excitation and rate of spontaneous de-excitation. Only then you have to come across the equilibrium condition, substitution and simplification of the equation. So that equation should be up to, derivation should be up to the expression for the energy density. You have to compare this equation with the Planck's energy equation. On comparing, you will get the parameters A21 by B21 and B12 by B21. You have to explain the inference. Only then the answer is complete. If you simply write the mathematical expressions, you lose part of the marks. For example, this derivation is for how much? For 10 marks. If you simply write only the mathematical equations, you may get 5 or 6 marks, and if they are correct. Without explanation, do not write the equations. And in this question, requisites for a laser system. And some students have a confusion between requisites and conditions. Conditions means population inversion and the metastable state. But requisites are the additional parameters required or the infrastructure required for a given system, laser system, for producing the laser. They are source of excitation, active medium and resonant cavity. These 3 points to be discussed for requisites. and you need to solve the problem using this n equal to lambda pt by hc formula for this equation. Describe construction and working of semiconductor laser. This requires the diagrams for both the construction and the working. We have observed in previous examinations during the evaluation that some students do not write the diagrams. If you give explanation without diagram, in most of the cases it is invalid. Usually marks will be 0. So that do not write the answers without diagrams. Diagrams are essential because you can explain the energy level diagram or the transition of electrons only with reference to the diagram. So if you forget drawing the diagram, then there will be no point in writing the paragraphs. You have to derive the expression for numerical aperture in this question and also to discuss the condition for ray propagation. This diagram is required for this, and in most of the answers which we observed in earlier evaluations, we found that this diagram was missing. That should not happen because you are writing all the steps with reference to the diagram. And sin theta naught, you are talking about sin theta naught, sin theta 1, sin theta c, it is not shown here, sin theta c should come here, means critical angle. So all those things are with reference to this particular diagram. So the diagram is required, and after the diagram only you can write these equations and explain each and every step. Condition for ray propagation to be described. It is very simple that angle of incidence should be smaller than the acceptance angle at the cross section of the core, that is at this point. Theta naught is the acceptance angle. Any light ray that enters into the core with the angle of incidence smaller than theta naught can undergo total interreflection at the core clad interface. Therefore, this is essential. You have to write that particular statement. That is the condition for ray propagation. And sin, if theta I is smaller than theta naught, obviously sin theta I is smaller than sin theta naught. Sin theta naught means numerical aperture, and it is derived. This is the expression derived. This is the problem on ratio of population of atoms in the upper state to that in the ground state. You have to calculate using this Boltzmann factor. On simplifying, you will get the expression for lambda and find out the answer. This is how to write the answers. Try to compare all these answers which have